In this video, we'll generate the physicist polynomial, Hermite polynomial, and the probabilist Hermite polynomial of the range from -1 to 1.1 and to the degree 10th. So data validation, our n will be to the 10th degree over the range from 1 to 10. And so we can start with 1. And the value of k will be from 0 to 0.5n. So sequence 0.5 times n plus 1. One column increment from 0, starting from 0, incremented by 1. So at n equals 2, n equals 3, n equals 4, to n equals 10. Now we continue with the expansion coefficient with the physicist Hermite polynomial. So array formula: -1 raised to the power k times 2 raised to the power the quantity n minus 2k, n minus 2 times k. Next, factorial n minus k. So factorial n minus k. And finally, combine n comma k. So combine n comma k, n comma k. Now the denominator, that is factorial n minus 2k. So n minus 2 times k. Then enter. If this is empty, this should be 0. So we correct this. Now if k is empty, and 0, otherwise calculate. Now we continue with the expansion coefficient, the series sum expansion of the Hermite physicist Hermite polynomial. So array formula: series sum of the x values raised to the power n minus 2k. So it starts with n incremented by minus 2. It's n minus 2k. And the coefficient will be this range. Continue with the probabilist Hermite polynomials. Start with the expansion coefficient. So array formula: -1 raised to the power k times factorial, that's n minus k. So n minus k. And the third part, let's combine n comma k. So n comma k. That's for the numerator. Now we continue with the denominator. So this will be divided by, there are two parts, factorial n. So that's factorial n minus k. So n minus 2k, 2 times k. That's the first part. The second part is 2 raised to the power k, 2 raised to the power k. If this is empty, it should be 0. So we correct this. So if k is empty, then 0, otherwise calculate. Now it's corrected. Now we can complete the Taylor series expansion. So array formula: series sum of the x values raised to the power n minus 2k. n minus 2k starts from n incremented by minus 2. and the coefficient will be this range. And we'll chart this. Insert chart. And we use scatter chart. Show row 1 as header. For the series, show the trend line. The type, polynomial. The degree, 10th. For the label, use the equation. For the legend, position at the bottom. Now here's our trend line and polynomial to the 10th degree. We calculate this polynomial regression coefficient using LINEST. To do that, we complete the LINEST matrix, starting with the elements of the matrix. So, array formula of the x values raised to the power 0 to 10. And the LINEST matrix, the LINEST function, data y, that is the physicist Hermite polynomial, and data x. Next, the coefficient for the probabilistic Hermite polynomial, LINEST, data y, and data x. Now we can start from 1. At n equals 1, our physicist Hermite polynomial is 2x. Probabilist is 1x. At n equals 2. So this is the physicist is 2x squared minus 2. The probabilist is 1 minus x squared minus 1. So this is x squared minus 1. N equals 3. That's 8 minus 12x. 8x cubed minus 12x. And this is x cubed minus 3x. N equals 4. This is 16x to the 4th minus 48x squared minus 12. So 16 minus 48 plus 12x. And for the probabilist, 1 minus 6 x to the 4th minus 6x squared plus 3. N equals 5. So that's 32x to the 5th minus 160x cubed plus 120x. So 160x cubed negative 160x cubed minus 120. So, and this one is 32x to the 5th. For the probabilist Hermite polynomial will be x to the 5th minus 10x cubed plus 15x, x to the 6. So here we have 64, that's 64x to the 6, 40 minus 480 x to the 4th, 720 x squared minus 120. And in the case of the probabilist Hermite polynomial, x to the 6 minus 15x to the 4th plus 45x squared minus 15. That's this range. X to the 7th. We have 128 x to the 7th minus 1344 x to the 5th, and this will be 3360 x cubed minus 1680 x. In the case of the probabilist Hermite polynomial, we have that is 1 x to the 7th minus 21 x to the 5th plus 105 x cubed and minus 105 x, x to the 8th. So here we have 160. This is 160. So 256 x to the 8th minus 358 x to the 4th and 13,440 x to the 4th. This one is minus 3,584 x to the 6 and negative 13,440 x squared and 1680. In the case of the probabilistic Hermite polynomial, we have 1 x to the 8, and this is 28, negative 28x to the 6, 210x to the 4th, minus 420x squared, and 105. And x to the 9th, n equals 9. So 512, that's 500, negative, that's 512, and this is negative 9216. This is 48,384 minus 80,640 and 30240. In the case of the probabilistic Hermite polynomial, we have 945 here, and this is negative 1260 x cubed. This is 378 x to the 5th, and this is minus 36 x to the 7th, and x to the 9th, and x to the 10th. So here we have this polynomial to the 10th degree. So 1024, negative 23,040, 161,280, 403,000 minus 403,200, and 302,400 minus 30,240. In the case of the probabilistic Hermite polynomial, we have here negative 945, this is 4,725 x squared, that is negative 3150 x to the 4th, 630 x to the 6th, negative 45 x to the 8th, and 1 x to the 10th. So this completes the use of the combined function, LINEST polynomial regression, and the series sum, Taylor-Maclaurin series sum, to generate the physicist and the probabilistic Hermite polynomial.